Hi everyone. So today we'll be looking at probability part 2. So we'll start with learning how to interpret Venn diagrams and then look at conditional probability as well as some questions with it. So I've drawn this Venn diagram here. So Venn diagrams essentially just show relationships between sets and their elements. So as you can see, A and B over here are subsets of U, which is the universal set, because you can see that these two sets come under U, so U is the universal set. And we can also see that they don't have any intersection between each other, so we can tell that A and B are mutually exclusive because the intersection is 0. And then 9 and 1 are just values that belong to the universal set, elements that belong to the universal set, but neither of these two subsets. Okay, now let's look at another Venn diagram with a universal set from integers from 1 to 8. So again, let's take U as the universal set and A and B as the two subsets. And then suppose if I put 1 over here, 2 over here, and then let's make another subset as C, suppose. And then we have 7 in the center here. 6, 4, 5, 3. I'm just assigning random values over here just to cover all of the integers from 1 to 8. So yeah, we have them all here. So now let's look at the properties of this Venn diagram. So let's look at A complement. A complement is essentially just all of the elements that are not A. So we know that 1, 2, 7 and 6 belong in A. So that means that 3, 4, 5 and 8 are things that don't belong in A. So the complement of A is 3, 4, 5 and 8 because they're not in A, right? And then A and B, which is the intersection of A and B, is just 2 and 7 because it would be this area. So that is 2 and 7, or it could just be written as in this set form 2 and 7. And then A and B, A or B, which is taking all of the things into account, is 1, 2, 3, 4, 6, 7, right? So everything except for 5 and 8 essentially. So 1, 2, 3, 4, 6 and 7. And then the complement of this, as we saw, is everything except for 5 and 7. And remember, when we're doing complement of A or B, the whole thing, then we have to put in brackets. If we wrote it as just A complement, A or B complement, the complement would only be to B. So it'd be A or B complement. So we need to be careful of how we write it. Okay, so A or B, the whole complement, would be just 5 and 8 as we saw, because those are the elements that are not part of this. And then let's look at an example of where the complement is not in the bracket. So that's A complement or B. So then we would be looking at everything that's not in A and then also B. So we'll be looking at this and then B as well. So that is 3, 4, 5 and 8 and or everything that's in B. So that's 2, 3, 4 and 7. So we just combine them since this is OR. So it will be 2, 3, 4, 5, 7 and 8. So that's how we would look at this, and this is 8 to just clarify. So this is how you interpret Venn diagrams. Now let's look at conditional probability. Okay, so conditional probability is essentially just the concept of the probability of an event happening given that another event has already happened. So the notation of this is P of A, and then the line over here represents given that B has happened. So this means P of A given that B has happened, or like B is happening. So over here your sample size gets reduced to just B, because rather than looking at the entire space, you're looking at the event A happening when B is happening also. So B is now your reduced sample space. So how you would solve this is you would take the intersection of A and B. So P of A and B over P of B, because we know that now the probability the sample space is B. So that is, as I said, the intersection of A and B out of B, because that is when both things are happening while the sample space is B. So this, and then another way of doing this is probability of B given A into P of A by P of B. So let's look at an example. I'll draw a table and show it to you, and then we can look at how conditional probability would apply over there. So in this question, we need to find the probability of a student taking biology given that they're a female. So in this table provided, we can see that there are a total of 10 male students and a total of 15 male students and a total of 25 students in general, and then 13 who have taken bio and 12 who have taken chem. So now we need to see how many people are taking bio given that they're a female. So you could just look at it as 10, because bio and female, we need to look at the intersection as seen earlier. So this is the intersection of biology and female, and then the sample space is the female, so this is the total sample space. So we would simply just do 10 over 15, which is 2 over 3. So the probability that a student takes bio given that they're a female is simply just 2 over 3. Or how you would look at it, if it's a bit more complicated of a question, you should actually follow that formula which I've provided. So this is just a simplified version, but if we were to follow that, we would see that probability of HL intersecting with female in all of the students is 10 out of 15 or 10 out of 25, and then probability of female is 15 out of 25. So we will take this over this. So then we have 10 over 25 over 15 over 25. So that's just 10 over 25 multiplied by this reciprocal. So that's 25 by 15. So again 25 cancels out. Divide by 5, so that's 2 and 3. So again we're left by 2 over 3. So that's how you would solve a question that's like this. Now let's go into some more complicated questions. Okay, so in this question, we're being asked that there are 40 students and 25 of these belong to a jazz band. So the rest 15 don't belong in the jazz band. Now in the jazz band, a student can play one of or two of or all three of these instruments. The saxophone, which will be represented by S, the clarinet, which will be represented by C, or the drums, which will be represented by D. And then we've been given these statements below, which will help us figure out how to draw the Venn diagram. So first, pause the video and try to draw it by yourself. I've already done the first one for you because it's quite easy. And also that 15 of them will be outside because 15 of them are not in the jazz band. So fill in the Venn diagram and then return once you're back. Okay, so I hope you were able to get this. So this is the proper Venn diagram for this description. Now we need to find the number of students who play the drums only. So from the Venn diagram we can clearly see that the people who only play the drums are 5 people. So the number of people would be 5. Then we need to find out the probability that a student chosen at random from the entire class, so the sample size is 40, plays only the saxophone. So the people playing only the saxophone are 4 and the sample size is 40, so it will be 4 over 40, which is just 1 over 4. Then we need to find out the probability that a student chosen at random from the entire class plays either the clarinet, the drums, or both. So we'll be looking at this entire area, and that will give us 21 because 4 plus 5 is 9, 9 plus 7 is 16, 16 plus 7 gives 21. So that's 21 out of 40. So we leave it at that. And then we need to find, given that a student plays the saxophone, so now our sample size is reduced to the people that play the saxophone, which is 8 plus 8, 16. We need to find the probability that he also plays the clarinet. So out of 16, 8 of them are also playing the clarinet, right? Because these two are also in the clarinet circle. So that means we'll have 8 out of 16, which is just 1 over 2. So given that a student plays the saxophone, the probability that they also play the clarinet is half. So this is how you would look at a question which is like this. Alright, that's it for today. I hope you learned something new. I'll be posting another video on probability so that we can practice a few more questions. Thank you.